Hello, everyone, and welcome back. So, before you start studying software testing, especially the ISTQB Foundation Level V4, and whether you are studying from our course, a different course, or even just studying from the syllabus, you should consider one aspect that will make learning V4 foundation level and software testing in general a very smooth experience. So, software testing, particularly its fundamentals, is a relatively straightforward subject that I personally enjoy exploring. However, one common challenge that I observe when many students tackle this topic is the interrelation of various concepts, regardless of the information source you choose to utilize. For instance, let's consider the official ISTQB syllabus. In the first chapter, under one of the earliest sections titled Testing and Debugging, you can see that it discusses how testing identifies software failures through dynamic testing and detects defects through static testing. However, to fully grasp these concepts, we need to refer to Chapter 3 and 4, in which we will take a deeper look into static and dynamic testing. Additionally, within the same discussion, we encounter regression testing, a concept that will be further elaborated upon in Chapter 2. So you can see that this interconnectedness illustrates that learning testing and debugging necessitates a comprehensive understanding of these related topics. So I thought, why don't we just take a quick look at most of the syllabus main concepts and terminology so we can alleviate some of the struggles we face when we encounter this domain. So, if you're new to software testing in general and you're willing to study the ISTQB Foundation Level V4, I recommend watching this video and I'm sure it will help you a lot. So, let's waste no time and let's attempt to consolidate the concepts and terminology of software testing, or at least most of them. So, no one can deny the importance of software in our lives. Problems or issues with any software while operating can cause many negative consequences, including loss of money and time. So, software is developed using a process called Software Development Lifecycle, or SDLC for short. Several processes take place in it, but it usually begins with team collecting requirements. These requirements represent the required features we want to have in our software. So we can say that the app should allow the users to sign up with their email addresses is a requirement describing the sign-up process for a particular software. Then the team creates something called user stories, which are simple statements describing these requirements, but from a user perspective point of view. It sounds like this. As a new user, I want to be able to register with my email address so that I can begin using the software. Anyway, each user story has its own acceptance criteria, which are conditions that software must meet in order to consider this user story complete. Developers use requirements, user stories, or acceptance criteria as a reference to understand the required software functionality and then write the all-famous code responsible for bringing the required features to life. After all features are developed, software gets released to the public in a process known as deployment. Of course, not all SDLCs are created equal. Some may perform the development process in a straight line, So we start with requirement gathering in one day and move through other steps with no way back. Such development method is called sequential SDLC, while other SDLCs repeat the process in cycles called iterations or increments. And in each iteration, we add a feature or a set of features to the software. So maybe in this iteration, we will write the code for the sign-up feature, and in the next iteration, we will write the code for the login feature, and so on. Now, let's talk a little bit about software testing. Software testing is very much attached to the SDLC in almost all phases. So, in the code implementation phase, we perform what's known as unit testing, in which the written code is tested for any issues. Similarly, when the system components or units are integrated together, unit integration testing is performed to verify that these components work well in harmony. Think of integrating the login and the sign-up feature, where a user signing up can directly use his credentials to log in. Of course, there are other test levels such as system testing, in which we evaluate the functionality of the whole system. And then we have acceptance testing, in which we validate the complete user experience of the software. One last thing about this point: requirements, user stories, code, or any other product of the development and test processes are called work products. Now, software testing is a well-defined process consisting of a set of test activities that aims to find these issues in any test item. It's not a random process by any means, so it starts with planning and designing and then performing the tests itself, which is called test execution. Test execution is often performed using test cases as a well-structured investigation methodology. These test cases include several elements such as how the test steps are going to be executed, the test data required to perform the test, what are the expected results from this test, and what test environment we are going to use while performing this test case. Of course, software testing is not only concerned with finding problems in work products, which is called verification, but also evaluates whether the software is suitable for the end user, which is called validation. Also, software testing is not limited to functional testing, in which we check if the software works as intended. Software testing extends to evaluate the quality of the software, such as security and performance. These kinds of tests are called non-functional tests. Now, to be able to do this verification and validation thing, we perform two types of testing. One is called static testing, in which we perform testing on work products without running them. For instance, we can examine the user stories to check for any contradictions or gaps. These gaps or issues detected using static testing are called defects. Static testing is one of the earliest stages of software testing and is usually performed during sessions called reviews, where the team investigate work products to identify defects during these sessions. The second type of testing is called dynamic testing, in which we perform testing on executable work products such as the code or the complete software. Here, we must run the work product or software to invoke failures. Now, what would happen if we actually find a defect or a failure? Well, finding failures in software testing implies performing different steps. The first step is to generate a bug report. This bug report, or so-called defect report, is our way of describing what are the issues found in the software. We describe everything in them, and we can also include screenshots and video recordings of the issue so that the development team can investigate the issue and then remove it. Now, after writing the defect report, most people might think that we need to fix the problem, a process called debugging. This is true, we must remove the issue, of course, but the most important action to do before debugging is to understand why this issue occurred in the first place. This process of investigating the reason behind the issue is called root cause analysis, or RCA for short. Now, we have written the defect report, we have analyzed what are the reasons behind the issue using RCA, and we have fixed the issue with debugging. So, are we good now? Of course, we have to make sure that the defect is actually gone for good. So, tester has to recheck the feature post-fix to ensure that the issue is actually removed in a process known as confirmation testing. And because fixing failures usually implies changes in code, we perform what's called regression testing. This is to ensure that changes introduced during the fix hasn't affected any other part of the system negatively. Regression testing is not limited to checking the system when a change is introduced after fixing failures, but also after each cycle in iterative or incremental SDLC. This is to check that features introduced during the current cycle did not break any existing other features. So it makes sense to create a set of automated test cases that we can run effortlessly after any change introduced to the system. Now you can see that a lot of activities and tasks are taking place during the test process, and a lot of information is collected along the way. This information is called metrics. Metrics help us understand the current status of testing. Something like how much we have made in the test process is called test progress metrics. And how many defects are found in something like the code is called defect density, and so on. So these metrics are usually communicated in a report called the test progress report. A variety of people interested in the SDLC, known as stakeholders, use the information and metrics collected in these test progress reports to understand our current situation and take the required corrective actions if required, in a process known as test monitoring and control. Furthermore, this report helps in risk analysis and control, in which we determine the threats endangering our project or our software and help us find solutions to mitigate them. Speaking of reports, another well-known report type is called test completion report, which is generated after each test cycle, test iteration, or even after project completion, so we can understand what went right and what went wrong during the previous period. Now, we would love to test everything in our software to ensure no bugs are hidden. This is a heroic goal, no doubt about that. However, this can imply testing becoming an endless process, something called exhaustive testing, which is impossible, by the way. but we really want to make sure of testing everything. The solution? Test techniques. So, test techniques are methodologies that evolved over time to help us achieve the greatest test coverage with decent efforts. There are techniques that depend on the tester's experience, known as experience-based testing. One famous experience technique is called exploratory testing, in which the tester explores the software and learns about it while finding possible issues. There are also other techniques such as white box techniques, in which the tester examines the internal structure of the software, such as the code or flowcharts. Or we can just examine the functionality in comparison to the requirements, which is called black box test techniques. Now, if you think this is too much to handle, I have good news. We can get precious help from tools to aid us with the test process. So we can use a variety of tools such as test management tools that manage the entire test process, test execution tools that automate test case execution, or communication tools that help us communicate test reports, and much more. Alright, I believe this was a long one. We encountered a lot of new terms and acquired some basic understanding of the test process. Of course, as we proceed with this course or any other course, you will begin to gain a deeper understanding of these concepts and learn new ones too. And now we can actually begin with our journey in software testing, and you will find things much easier, more fluid and understandable in one way or another. And that's the point of this video.